What if I told you humanity has already tested a way to protect Earth from an asteroid impact? In 2022, NASA did the impossible. A small spacecraft, no bigger than a vending machine, intentionally crashed into an asteroid moonlit millions of kilometers away and changed its orbit. This wasn't a Hollywood movie. This was real, and it marked the first time in history that humans deliberately altered the motion of a celestial body in space. Welcome to Top 10 Explorer, your home for technology, science, and the future. Today, we're diving into the story of DART, NASA's double asteroid redirection test, and how this single mission could one day save our planet. Section 1. The Asteroid Threat. Every year, thousands of space rocks known as asteroids pass near Earth. Most are harmless, but a few come dangerously close. You might remember the Chelyabinsk meteor explosion in 2013, a rock barely 20 meters wide that shattered windows and injured over 1,000 people in Russia. Now, imagine an asteroid hundreds of meters across. The damage could be catastrophic. Earth has faced mass extinctions before, like the one that wiped out the dinosaurs 66 million years ago. That was caused by an asteroid impact. Scientists know it will happen again someday. The only question is, will we be ready? That's why NASA created the Planetary Defense Coordination Office, a global initiative to detect, track, and, if necessary, deflect hazardous asteroids. And their first big experiment was DART. Section 2. Mission Overview. DART stands for Double Asteroid Redirection Test. Its goal, to test whether a spacecraft could change an asteroid's path using nothing but kinetic energy, that is, a high-speed impact. Launched on November 24, 2021, aboard a SpaceX Falcon 9 rocket, DART's destination was a double asteroid system known as Didymos and its smaller moonlet Dimorphos. Dimorphos is roughly 160 meters wide, about the size of the Great Pyramid of Giza, and orbits the larger Didymos every 11 hours and 55 minutes. By crashing into Dimorphos, scientists hope to shorten that orbit by at least 73 seconds. Even a tiny change in orbital speed would prove that we can alter the trajectory of an asteroid through impact. Section 3. The impact. After nearly a year of travel through space, DART approached its target. Guided by an onboard camera called Draco and autonomous navigation software known as SmartNav, the spacecraft locked onto Dimorphos. There was no manual control, no second chances. The final images streamed back to Earth in real time as the asteroid's surface grew larger and larger until the screen went black. At 14,000 miles per hour, DART slammed into Dimorphos 11 million kilometers away from Earth. Just before impact, a tiny companion satellite called LISIA-Q, developed by the Italian Space Agency, captured the collision from a safe distance. The footage showed a massive plume of debris bursting from the asteroid, a cosmic explosion of dust and rock. Section 4. The results. Days turned into weeks as telescopes on Earth and in space tracked Dimorphos' orbit around Didymos. Then, the data arrived. The orbit hadn't shortened by 73 seconds, it had shortened by 33 minutes. That's 25 times more than expected. The debris ejected from the impact acted like a rocket booster, amplifying the effect of DART's strike. It was the first proof that humans could intentionally alter the path of a celestial body. NASA Administrator Bill Nelson called it a watershed moment for planetary defense. And rightly so, this was the day humanity proved we are not helpless in the face of the cosmos. Section 5. Scientific Discoveries. DART didn't just deflect an asteroid. It revealed how these objects behave when struck. Before the mission, scientists didn't know if Dimorphos was a solid rock or a loose rubble pile of gravel held together by weak gravity. The impact showed that it was indeed a rubble pile, which explains the enormous cloud of debris. That knowledge is priceless. Future missions can now be designed based on the structure of an asteroid, whether to hit it, push it, or use gravity to nudge it aside. The European Space Agency is already planning Hera, a follow-up mission launching in 2026 to study the crater left by DART and measure its precise impact. Hera will map Dimorphos in 3D and help refine deflection models for future planetary defense efforts. Section 6: Global Collaboration. One of the most inspiring aspects of the DART mission was how international it was. Dozens of observatories from around the world, from Chile to South Africa to Hawaii, contributed to tracking the aftermath. It was humanity working together, not as separate nations, but as a single species protecting its home world. NASA's collaboration with the Italian Space Agency, the European Space Agency, and other global partners marks a new era of planetary cooperation, not just in exploration, but in defense. Section 7. What comes next? DART isn't just a NASA story, it's a global mission. Observatories worldwide tracked the impact, the trail of ejecta, and the orbit change. NASA's European partner, the ESA, is launching its Hera mission to the Dimorphos system in 2026 to map the crater and measure the asteroid's properties. Planetary defense is no longer science fiction, it's international cooperation. This mission shows that we could one day redirect a real threat, not just simulate it. We live on a planet in motion surrounded by space rocks, both tiny and giant. So, when you look up at the night sky, remember that one day, a spacecraft did slam into an asteroid and shifted its path. And for that, our world is a little safer. What do you think? Will the next mission save Earth? Or is the threat still too big? Drop your thoughts in the comments, like and subscribe to Top 10 Explorer for more tour of the tech shaping our universe. Because the future of cosmic defense is here and our survival depends on it.